There are three basic types, Mr. Pizer: the wills, the won'ts, and the can'ts. The wills accomplish everything, the won'ts oppose everything, and the can'ts won't try anything.
Well, do us all a favor, Vincent, and try to be a can't, especially where that monster's concerned. We need you, not another corkscrew.
Hey, look at that. Vincent, you're gonna have the time of your life in there.
I don't mean to sound superior, but I hate the company of robots.
So try and relax, have some fun. Remember what they say, all work and no play?
All sunshine makes a desert, so the Arabs say.
We've been in some scrapes before, and we're gonna get out of this one.
No need to fear. You're in safety. know Bennings. I've known him for 10 years. He's my friend. We gotta burn the rest of them.
What's up, hackers? Welcome to Attack on Tuesday. My name is Taggart, and tonight we are diving into the world of mobile app pen testing. I have no idea what I'm doing. That's not entirely true. I know a little bit about what I'm doing, but this is definitely a new area for me, and it's something that I've always wanted to get into. I think a lot of people are interested in this realm, but maybe you're like me, and maybe you were a little bit intimidated because it's not nearly as accessible as, for example, web app pen testing, right? Because it requires a little bit of specialized equipment or at least software set up to get going. If you're not a mobile app developer, it can be a little bit intimidating to take a look at all this Java or Swift or whatever and kind of like break that down. So we're gonna get started with that today, and we're gonna use some of the OWASP tools that we were exploring last week to get started with it. So if you remember, OWASP has this amazing directory of free and open source vulnerable applications that you can use to start learning how to do application pen testing, application security. Hey, Alpha Echo, good to see you. Killer, good to see you. Honeypots, always a pleasure. And what's cool about the OWASP directory, other than it's free, is that it does break it down between mobile, offline, and online stuff. So last week we were playing with some of the hosted web applications that we could actually just play with on the web for free, like the AccuArt one. I think, what else did we went after Broken Crystals, which is meant to teach like going after modern web apps and APIs, things like that. Lots of cool resources in here, but we're going to take a look at some of the mobile ones today, and in particular, we're going to go after the Damn Vulnerable Bank and the Andro Goat. What's cool about both of these is they have guides if you want to follow them and kind of see how to look for these kinds of vulnerabilities. We're going to see what we can do without looking at the guides first, though, just to see what's up. Now, before we do anything else, we need to talk about how to get your environment set up to do this. And it's not crazy tricky, but it does involve more than one step, basically. So what we're going to do is, broad strokes, we are going to virtualize an Android platform. And we have a couple different ways that we can do that. And then once we virtualize the Android platform, we get the apps that we're interested in testing on them, and then we're going to proxy the network traffic through our research machine. In this case, I'm using Kali, and we're going to do that through Zap. So we're going to use a proxy to capture the web traffic. So that's going to be our dynamic analysis. We're not going to be doing kind of like live debugging of the application at this point, but we are going to be capturing the web traffic. And in many cases, this is going to be a lot of where we find potential vulnerabilities in the application, because the API is the thing that is vulnerable, right? So when we see the network traffic with the API coming out, we're able to capture it, perform replays, things like that. So this is going to be a great source of information. We're also going to take a look at some static analysis. And the way that we're going to do that is we're going to use JADX to explore the APK. We're going to kind of deconstruct it into the DEX code and then back into Java to see what the APK actually has in store for us. So that's the plan. Let's talk a little bit about virtualizing or emulating Android. There are kind of two big, easy ways to do it that I've found. And if you have another way of doing it, let me know. That's exciting too. I'm certainly still learning all of this myself. But what I have found is that there are basically two big camps for how to do this. The first one, all you need is a hypervisor. And that is with the Android x86 project. So with Android x86, it's a project that has, a version of Android that is compiled for x86. And you can run it in a hypervisor. So I'm running it in Hyper-V, and you can run it in VirtualBox if you want. No problems. Real easy to do that. It's just an ISO. It installs just like any other kind of ISO. So nothing crazy there. I will say, though, there are a couple of gotchas when you're running, and that's this right here. That's what you see. So a couple of gotchas when you're running the Hyper-V version of this, if you want to use Hyper-V on Windows. There are two ways to make a VM, right? There's Generation 1 and Generation 2. You have to make a Generation 1 VM, as I found, because if you don't, the bootloader just doesn't work. I don't know why, but it will never boot. So if you set it up for Gen 1, it installs fine. Everything works great. I had this up and running in maybe 10 minutes, less, I think. Real easy. Interestingly, in the virtualized environment, it does look like it thinks that it has Wi-Fi, right? Because it's connected to this thing called Virt Wi-Fi. Let's click on that and look at our Wi-Fi. Yeah, it's called Virt Wi-Fi, which is kind of interesting. So it has a network connection, and I can get stuff onto it. And in fact, I already have done. I've installed the AndroGoat. I'll add these to my start screen here. And the damn vulnerable bank applications. I've actually already loaded these on. And I did that through Chrome. I didn't do anything fancy like side loading with ADB or anything. ADB is like a command line tool for working with Android devices. Didn't have to, because I could just go to the site, right, and download these APKs. So no problems there. And if I needed to use like F-Droid or any other alternative app store, I could do that as well. But this does have Google Play on it, I think. Yeah, it has the Play Store on it. So if I wanted to get, an actual app that I wanted to research, I could certainly do it. This thing has the Google apps and the APIs ready to go. So that's Android x86. That's how you do it with that. The other way to do it, you can do APK install straight from browser. Yeah, that's how I did these, was straight from the browser. Now, you will get a little warning saying you have to set the permissions to allow APKs to be installed if they're downloaded from Chrome, but just hit yes, and then you're good to go. Absolutely right, Cheeto. Yeah, you don't need F-Droid, but I was saying, like, if you wanted to research something that's hosted on F-Droid, you could get it that way. Right, so this thing is set up. Let's talk a little bit about the other way that I found, and not what I wanted to be doing, but I think it was cool enough that it was worth checking out. Fury, thank you so much for the follow. So the other way of doing it is with Visual Studio. So here we are in Visual Studio, and what I've done is I've made sure with the Visual Studio installer, which I'll bring over here. Oh, dang, Cheeto, thank you so much for the sub. Is if I click on the build tools, I'll click on modify here. It's like it's already installed, but just so you can see it. I've installed the mobile development with .NET platform. And what that gives me, yeah. What that gives me is like Xamarin and other tool chains for developing mobile apps in Visual Studio, like actual Visual Studio, not Visual Studio Code. I'm talking about the full fat IDE here. But importantly, one of the things that it gets me is the Android emulator, along with the Android SDK. So that is super handy. I install that. I set up a new Android like demo app. I don't even actually have to do that, but it was just easier to get that going so you could see how this works. And then there's one other step that you want to take on Windows if you're doing this, which is if you set up Windows features, you want to turn on, make sure that in addition to Hyper-V, which if we're talking about virtualization, you already have that set, but you also want to make sure that you have the hypervisor platform hypervisor platform enabled. And what that will do is actually accelerate the Android emulator with Hyper-V. So your emulation will actually run through Hyper-V. Hey, Fury, here's what I'm going to ask you to do. Come join our Discord. There is a whole channel dedicated to Rust in our Discord, and you're going to get your questions answered about books and more. Okay, so once we have all of that busy work set up, what we can do is we can actually go here into our Android device manager in Visual Studio. And you can actually already see I have one running here, but I can create as many phones, right? Or as many devices as I want with different versions. I could set up different kinds of devices or at different levels of Android. So Donut, Xamarin is still hot. It is still a legit cross-platform, framework for developing mobile apps. It's still around and actively developed. As a matter of fact, Microsoft acquired Xamarin a couple years ago. Oh, throwback for you, yeah. So anyway, once you have this set up, this is what you get. It looks just like this. Pretty wild, right? Unacceptably chilly here in Los Angeles, 55. But as you can see, I've done the same thing. I've installed these in both locations. What remains is for me to set up the proxy in both of these, and they work slightly differently. The way that this version of Android works for setting up a proxy is a little bit different. Look how buttery that emulator is. Is this with Haxum? It's not, Donut. This is actually running through Hyper-V. Can you use the same program to emulate ARM64? Yes, you can. So if we go back to the Android manager, let's make a new device just so you can see that. And so I can have a Pixel 5, whatever, and I just change my processor down to ARM, and I can absolutely do that. Now, I don't know if I can set up ARM devices to run through Hyper-V, so it might not be as smooth, but it definitely works. And of course, you can set up all your like configurations, how big the disk is, what sensors you have available to you, all that sort of stuff is right here. Yeah, so pretty rad. I was actually excited. This is a whole lot easier than when I used to teach mobile app development, actually, believe it or not, and I was using Android Studio at the time, and that was not a great experience, I have to tell you. This is a lot easier to get things up and running. So, full marks to Visual Studio on that front. As you can see, I've got all my controls over here. I can quick power it down if I need to. But let's do some proxy stuff, just so we can see how that works. Let's do it in the Hyper-V version of the machine first, because that's the weirder one. There's like a whole thing that you have to do. Yeah, so in the Android x86 project version of this, you actually have to run terminal commands, if you can believe it. I know that is crazy small. I don't know if I can make the text any bigger. Preferences. Maybe I can. No. All right. Also, I'm going to change it up to some chill synth because this is a little much. Yeah. Nice and easy. Easy listening. Okay, so basically it's a one-liner here. And what we're going to do is we're going to do settings put global HTTP proxy. And I think I have this thing set up on my local LAN. So 192.168.1.114. 8080. Oh, do I have to be like sudo-i? How about just su? Can I become root? Ah, yes, good. There we go. Let's try that one more time. It feels so weird to be entering commands like this for Android, but I mean, it is built on Linux. So settings, put global HTTP proxy 192.168. 80.1.114. Come on. 8080. That should be it. And I've already configured over in Kali, good old Zap. I've configured my local proxy to be listening here on that address. So if all has gone according to plan, if I were to open up Chrome right now and go to a new site, would you look at that? Now, I'm going to get a bunch of SSL errors right now because I don't have the cert for Zap. Now, I can fix that pretty easily. And in fact, I should, to make this work correctly for the rest of the test. But as you can see, the proxy is working just fine. So how are we going to do that? We're going to download the proxy. We're going to save that out. It's already there. And we'll run an HTTP server on this thing. And back to Android. So we'll go to http://192.168.1.114 8000 and get the cert. And I actually have no idea what to do from here. Oh, that would be what... Okay, Chrome actually had me sorted. So if I go to downloads and I open this cert, perfect. Credential use, VPNs and apps. Yeah. Oh, okay. I'll set a password. Or a PIN. No, you're right, Sar. I don't think you can do it. Choose my pattern. Z for Zap. All right, thanks for hanging out, Alpha Echo. Enjoy time with the missus. All right, fine. All right, now can I please install? Oh, the cert is installed. It was that easy? All right, let's try going to Taggart Tech one more time. That's not how you spell my name. A-R-T. And we're set. Okay, so that's how we take care of that. Let's go ahead and set that up over in the Visual Studio version of this right now. 192.168.1.114 8000. It's so tiny. Must be installed in settings. Only in CA. Only install. Okay. So I will do that. So funny. There we go. Settings. Certificates, maybe? Install certificates. CA certificates. Perfect. CA certificate. Install anyway. Dope. Now, in terms of setting a proxy, how do we do it? To set a proxy here, it's actually a little bit easier. I'm going to go into our Wi-Fi settings here, and I go to Edit, Advanced Options, Proxy, Manual. That's it. 192.168.1.114. Proxy port 8080. Save. Okay. And now if I go back to my browser, let's go to CNN.com. Because we all need some good news. Okay. Well, obviously that worked. It's always a nightmare going to CNN, because look at all the crap that gets loaded. Just terrifying. Look at this. So, sorry, there's a way to emulate it. Well, there's a way to go the other way, because that's what Apple does, right? You can go from ARM to x86. That's what Rosetta does. Yeah, that's why I run a Pi hole. It's good to see it, though, right? To have this laid bare. All right, so we've got our proxy set up, so we're actually good to go. Although, God, I gotta like get off this site. It's so nasty. Update Chrome. I'll update Chrome. Let me just close this tab. Now, let me just ask chat. So, of these two different versions of the Android operating system, which one is feeling better to you in terms of usage? Maybe it's too early to tell. The one that did not visit CNN. I mean, yeah, I mean, this one's a little bit, I think this one's a little bit less responsive, but I don't think it's going to make a difference for us. This one has, I think, less setup overhead, so we'll try to continue with this. So we're going to fire up the damn vulnerable bank and see what we're up to here. And if we're happy with this one, I'm going to power down the other one, at least for now. So I'm just going to power that off. It saves the state for me. How cool is that? And I'll leave Visual Studio open in case we decide we change our minds. But for now, we'll hang out in the x86 project version of this. All right, damn vulnerable bank. Here we go. It just said phone is rooted. So what just happened? It said phone is rooted. Is it open? Does it not run if the phone is rooted, I wonder? That's interesting. Maybe we are using the other one. Maybe using attestation page. Yeah, maybe. Well, let's see what's up with this. If we can't get the dynamic running, we'll go over to static and see what's up. Boop. Turn it on. Let's see what this does. Does the same thing. Interesting. All right, let's try some static analysis and see what we can learn. So to make that happen, we're gonna go get the damn vulnerable bank APK from GitHub. And over on releases, and we're just gonna save it. Documents, OWASP, DVB. All right, and I've already loaded JADX, which is a tool for static analysis of APKs. I'm going to run something called JADX GUI. Let me zoom that in a little bit. I think I had this zoomed out to do actual work rather than streaming work. But yeah, so JADX GUI is going to load up. It doesn't look great, but it does work. So we're going to go to OWASP DVB and give it the DVB APK. And as you can see, we now have information about the package. So some things that we always want to take a look at. You want to check out the manifest.xml to see what it's planning to do on the device. And then activities, which are essentially views in the app. So there's reset password, view beneficiary, approve beneficiary, pending beneficiary, send money. Main activity, which is kind of where everything kicks off, and then the splash screen. All right. Inside of the source code, we can go down into its own source code here. There's the main activity. And this is what the source code looks like. Hello. Looks like we got some base64 encoded data here for health check. Is that C++? It is Java. Okay, that's still encoded one way or another. As you can see, it's decrypting, so that's interesting. Is there a hard-coded key somewhere? I want to look for rooted. Because that toast is should be an intent somewhere. There it is. We found where the toast happens. So if a.a.a.a.r, whatever that function is, toast.matex get application context phone is rooted and just dies. So that's like right up top on create. So we got to see what this is. A.a.a.a. 5 A's for A dot R into B I getting there O Q R. Throw new unsupported method not decompiled. Interesting. So we didn't get to see what this function is, but obviously we know what it's doing, right? It's saying if the phone is rooted, you can't run it. Well, that sucks. Not exactly what I wanted to see for our first app. Out of curiosity, does the same thing happen with AndroGoat? Nope. That one works fine. So we might focus on AndroGoat, since that seems like a little bit more fun to play with. Although while we're here in JADX, let's see what we can see just from a static analysis of the code here. So going back to the main activity, we see the login page. And the health check, which is some data. And some decryption, which we might dive into, but... register bank is the activity when we do the sign up page. So look at this. We can see the API, right? API user register. We're setting up username, password, and then encoded data, whatever the encoded data happens to be. E.B. So where's E coming from? View. There it is. Go to declaration. So if you just follow what we just did, so we found that when you're registering, Dovahkiin, thank you so much for the follow. If you're registering, if we're reading this code right, you get the API URL, which we can maybe check out someplace. It might actually be in Android Manifest or some other places where there's some static resources. But API URL, API user register, right? And then with the user register, what are we sending to it? We're sending a JSON object that has a username and password, and then some encoded data. Well, what's the encoded data? You know, maybe it's extra information about the user, but it looks to me like it's actually kind of like almost like an XSRF token, where it's like, I am authorized to use this API, right? Well, how do we know that we're authorized to use this API? What are we saying? So we're encrypting something, which is a JSON object to string. And the JSON object is this here, just a new object to string. So it's like empty, looks like, unless I'm missing something. But I think it's just empty. And then, oh, there we go. JSON object dot put username, password, and then no. Username, password. So I think we're like encoding the data here, but we're encoding it a certain way. So what is that way? Well, it's E.B. What the hell is E? E is actually imported into this file from here. And this is kind of just like how reverse engineering goes. You can rename this stuff, but basically you have to get used to these weird variable names and just kind of walking them back. So we can see that CBAE, it's like musical notation on this one, is imported here. And what we did was we right-clicked on this and said go to declaration, which took us here. So E, F1256A was amazing dot length, whatever the length is. And if we remember what it was E dot B, so the function B inside of here. So it's base64 encode to string. C as a string, get bytes. So we're base64 encoding C. What is C? It's a new string from string. So we're base64 encoding that. It looks like we're double base64 encoding it, if I'm not... No, not the same way, but it looks like we're double base64 encoding it, if unless I'm misreading this. Oh, no. I am misreading it because I was going up to A rather than to C. So here's how C works. So we're using C. So for I equals 0, I less than string length, I plus plus. So we're looping over the entire string. And we're creating a new string. So stir2 equals stir2 plus the I XORed with amazing. The character at amazing mod by I. And the length of amazing. That's cool. So this is the encryption technique, right, that this app is using, where in order to encode our data, it's taking each character of our data, and it's XORing it with the character derived. The amazing is just an arbitrary string to XOR against? Yeah, and as a matter of fact, it's not XORing against that entire string. It's XORing against a character at a specific position. The specific position given by the position in the string we're encoding, modulo the length of the word amazing, which is what you see up here, right? There's that F1256A. That's what we're doing there, is we're saving that as the length of the string amazing. Yep. And so this is just like a hard-coded encryption key is what we're looking at here, which means that if we were to get this app to run, which apparently we can't, we'd be able to decrypt. If this is the encryption mechanism for all the traffic that it sends, we'd be able to use this to reverse it and decrypt all of the traffic being sent by this application. So hard-coded decryption keys in the app, no bueno. They can get reversed, and you can use that to decrypt data. Quick interest check. How are we liking this? Do we want to stay in JADX and keep poking at this app for a minute? Do we want to go down to do some dynamic on Andro Goat and see how that works working through Zap? How's everybody feeling? Because this is all exploratory for me. I don't have a specific goal in mind other than learning and playing with this stuff tonight. Neon, this is the Damn Vulnerable Bank, which is hosted by the OWASP web applications directory as a vulnerable Android application for you to learn how to do stuff like this. Oh, maybe we should do Goatlin because it has API and REST stuff in it too. Oh, except I'm not. No. That's not really. Just keep exploring. Honeypots is the only person with an opinion. All right. Back to JADX. Okay, so let's see. We obviously have the register bank. That's kind of easy enough to, register a user. Send money might be interesting. How does this work? So there's biometrics involved, if there's a biometric sensor available. Allow device credential. Okay. So when this thing is loaded, it sets the content view to layout, activity, send money. Okay. And then get intent, get string extra beneficiary account number. So there's a JavaScript or JSON web token involved here. Now let's transfer. So same deal, sort of. To account, amount, and encrypted data, e.b. So we're encrypting data the same way. It uses the same trick to do it. The only difference here is that we have a JavaScript web token, get shared preferences. Send money dot get shared preferences. So let me send money. At this, right? Okay. Get shared preferences. Oh, they're using Firebase too, which is a big no-no. All right, let's look that up. Let's look up get shared preferences. So I want to see where that lives. Shared preferences, thank you. Android developers. Interface for accessing and modifying preference data returned by context.get shared preferences. For any set of preferences, there's a single instance of this class. Modifications to the preferences must go through an editor object to ensure the preference value remains in a consistent state. So, what we would really want to know is if there's a set shared preferences someplace. All right, let's look for JWT by itself. So I'll get shared preferences, get shared preferences. So they use it often, right? Android content shared preferences. So if we go to Android, nope, material, nope. Not quite sure where shared preferences is living at the moment, but let's put a pin in that and see what else we can find. So, bank login. So this is where they're actually logging in, I think. Yep. So they're sending a token to see if they're logged in, it looks like. And if not, then they're going to do the thing. Username, password, encoded data. And the encoded data, as we saw, was just whatever is going into the JSON object. And then XORed, right, with characters from the word amazing. And presumably what happens on the other side is the encoded data is decoded by XORing again with those same characters. And if the if the decoded does not match the plain text, right, username and password, then it'll say, you know, you're not authorized to do whatever. So, like, in a way, the key is present. Like, you're not really encrypting the username and password, really. You're using the encryption data as almost like an XSRF token to prevent people from using the API without authorization. It's too bad that we couldn't get this thing running to try to test some of these theories. Yeah, I think without doing dynamic analysis, there's not a whole lot more fun that we can find here. Although we'll keep looking just a little bit. Let's see what else. Com, currency rates, dashboard, get transactions. View. So C2 Z.A. Where is Z? Go to declaration. There it is. Oh man. It's like a generic. I feel like I'm missing something here because it looks like API transactions view. Like we're doing a GET request. Maybe not. Maybe it is a POST request, but where's this? Yeah, like I'm missing where we're sending any sort of data to tell it whose transactions to get. Interesting. My profile is a little interesting. You can see that this is the data that we save here. The balance, account number, username is admin. Be cool if you could mess with that in real time. The account number, balance. Yeah. And it's all strings, notice. It's not getting parsed as any kind of object or anything. It's just looking at like the data itself. Very cool. Any questions about this? Does anybody have anything that they want to try to look into or see if we can explore any deeper? All right, we're going to try another thing that we might be able to do, which is cool. There, in theory, is a way to debug just, like, random APK files. What you got for me? Oh, crazy. Apparently there is a way to do it. I'm just kind of poking around for it. There is a way to, like, attach to an APK here. Project properties. Okay. Nope. Not there. I'll stop bothering with it. Let's go check out. Let's go check out Andro Goat. Oh no, it's gone to sleep. I don't have a good way of getting this to wake up. Oh, there it is. Hopefully I remember the pattern I set. I did. All right, so here's Andro Goat. Let's go back to Kali, close this. Go get that APK so we have both the static and dynamic ready to go. Andro Goat. We'll load that up in JADX as well. And let's see what it looks like in Android. So, Andro Goat is purposely developed open source vulnerable and secure app using Kotlin to understand and defend the vulnerabilities. Okay. Let's go for... Well, Anybody have any preferences? Look at these. Network intercepting, unprotected Android components, and secure data storage. There's a lot to learn here. This is really cool. Let's start with network intercepting, because I feel like we're going to be able to do this pretty easily. So we're objectives. 1, intercept HTTP traffic. All right, cool. I can do that. Request sent to demo testfire.net. Please intercept using proxy. I think we have that one covered. There it is. So sure enough, we already have that proxy set up, so we're good, right? All right, we've got that sorted. That wasn't too hard. Let's try HTTPS. Request sent to OWASP. We also got that. There's nothing interesting in the request, though. All right, so we know about how to do that. Certificate pinning. Interesting. Understand and bypass certificate pinning using different tools. Just trust me already. Frida, etc. Nothing's happening when I hit that. Understand network security config.xml. Let's see what we have. There's cross-site scripting. Very exciting. This is organized in a much different way. I think it's built a different way, but here we go. Here's all the activities for this one. Pretty large. Is rooted. So this is how it's looking for root. Is it's looking for system app superuser, superuser.apk, looking for SPNSU, which we know exists, right? Yeah, so it's looking for all these kinds of things to indicate that the device is rooted by these things' presence in the root of the file system. And then it's actually trying, so it is rooted 1. So it's actually, there are a couple different methods here that it's using to test, right? Can it look for data? Why would it need to know that? So as we saw, one of the apps, the other app we were running, didn't run if it was rooted. And there are some applications, because of security concerns, that will not run if the phone is rooted, because it depends on that section of the file system being unreadable by the user. And if that section of the file system is readable by the user, then it can no longer be considered secure. So some apps like this will check for root on startup and either just die or have some other pathway for you to follow, if that's the case. It's like less of a thing now, but it used to be a big deal to get your phone rooted so that you could do whatever you wanted with it. I even remember the bad old days of jailbreaking your not just your iPhone but your iPod Touch, so that you could do whatever you wanted with it. Good times indeed. Let's check out unprotected Android components. Okay, understand what is protected or exportable Android component. Activity services, broadcast receivers. Log in without PIN verification by launching the activity. Understand custom URL scheme. Log in using custom URL scheme. Set PIN. 1. Okay, I will set a PIN. PIN created. Please log in. Okay, but what happened? Did anything happen? Okay, no network stuff happened. But we might have to check something on the file system. It's a service created, invoice downloaded. All right. We may have to check out the guide here because obviously we're learning quite a bit. So the file browser that we want here, show internal storage. That's it. Thank you. Android data. Thank you. Well, let's go back up one. All of this is, I think, Android built in. We might need an alternative file browser to check out some of this stuff. I don't want to sign in. Ugh. Gross. There are, like, less than reputable APK mirror. That's what I wanted. Now, I guess we could also use the terminal for some of this. God, look at all this crap. You know what I should have done? I should have just done this on my phone. To look it up and then go to APK Mirror for exactly that thing. Because there's a specific file browser app that I have in mind that's going to work well for this. This is the thing with mobile app stuff. You have, like, so much stuff that you have to get set up. Astro. That's what it was. Boy, it's been a minute. $2015? You have got to be kidding me. Whatever. Ah, no. Damn it. Got me. There. Usually more bugs to be found because of the higher barrier to entry. Yeah, that's a fair point. I'm still not really, you know, chasing bug bounties. I'm more interested from an academic perspective here. But hopefully, if you're interested in bug bounties, this will be a way to get started. I think I already saved it, so let's go find it in files. The deeper you go into embedded devices, the farther back in time. That makes sense to me. Am I not hitting okay? Well, that was easier. Oh, downloads. There it is. A ton of these queued, none of them actually happening. Interesting. Okay, whatever. I'm not going to waste my time with that, because the whole point was... App private. Nope. There you go. So now we're looking at the app data. I know it's crazy tiny. But if we do cdcom.app, or no, cd, let's do OWASP. There's the base dot. Let's lslib. What's in oat? There's your dex. So that's the dex code. Which is, think of it as like, think of it almost like it's not really assembly, but it's like one level up from the, you know, running code. All right, we have some more to learn here, obviously, because we're poking around at stuff, but it's not entirely clear what we're looking at. So let's go back to AndroGoat, and in fact, let's go to the AndroGoat guide, because there is a guide here that helps us walk through this thing. And I think that's perfectly reasonable. At least I thought there was. Is there a wiki? Is there actually a wiki? No. All right, well then, we are going to have to search elsewhere. So the whole concept here was unprotected Android components. So let's look up that idea. Unprotected Android components. Hacking Android apps through exposed components. What you got for me? In almost every Android application, developers expose activities, right, without sufficient protection. Remember, activities are like views, right? Splash screens, login screens, anything that comes up as an interface. Exposing activities can lead to various attacks. For example, an attacker or a malicious app installed on the same device can call those exposed activities to invoke internal pages of the application. Oh, that's cool. Calling internal pages puts the application at risk of phishing by manipulating users to enter details in the phishing app, as well as exposing a user's secret pages, such as admin panels or pages which should have been visible to paid or pro users only. Okay. As mentioned earlier, activities expose the apps to human risk. So, a user with root permissions on the device can invoke any activity simply by sending an intent to the desired activity. Whoa. Now, ADB, we mentioned it earlier. ADB is a tool that you use usually from like a connected device. Yeah, it's not on here. So what we would have to do... AM. Oh! Hell yeah. So AM is actually on this shell anyway. Perfect. So we don't have to worry about ADB because we're one layer below it. But we do have the AM Android managing CLI that we can use. That's really cool. Okay, so we want to look for exposed activities. So we always look at the manifest, and we want to fire up the admin activity. Call it and see what we get. Okay. So let's take a look at our manifest. Secure logging activity. And how do we tell that they're... Can we exploit the SQL? I think we can exploit all of them. We're just picking which ones we want to go after right now. Now, the application part that we were in was the... login without PIN verification by launching activity. Okay, so... yeah, I think we're going to do the SQL injection next. I'm really interested in this. This is completely new to me. Unprotected Android. I've never done components like this, so I want to see how this works. So the idea is, can we get to like the download invoice section without entering our PIN, right? So this was unprotected. There's an SQL database as part of the APA. Yeah, there can be. Usually SQLite. What do you think it's called? Insecure storage, insecure logging activity. Access control view activity. There we go. Access control issue 1 activity. Access control view activity. Start service. All right, let's try access control owasp.sat.agoat access control view activity. So the way that we would launch this is am start, and then we give it the name of the app, and then the name of the activity. So got a lot of windows. I've got too many windows happening on this app. So we would try something like am start n. It's actually, where are we? Oh, perfect. We're in the right spot. So am start n OWASP dot appsec, or so OWASP.goat slash whatever. And then let's see if just that works. No. OWASP sat a goat. So we got to find out where we get that name from, because I think that's something that we're missing. Maybe we have to be in the directory. Okay, AM doesn't like start, so we're gonna have to look for something else that it does like. Start activity. Okay. So start activity. Start activity. And then we have to give it an intent. So that would be, again, OWASP set goat. Slash, and here we go. I think that works. So, unable to resolve it. So, now we go to, what is it? Access control. Access control. Is it just me, or is the, like... Okay, access control one view activity. Activity class does not exist. All right, let's look back into the manifest and see what we have here. Main activity, insecure logging activity. Input validation. Insecure storage activity. Let's try that. Okay, so saying the main activity does this, so we're missing something about the pathing here. These activities can be influenced cross apps, so you can attack an insecure app from another app. I mean, technically that's what we're doing, right? Because this terminal is another app. But I think what you would do, this is not so much remote. Maybe it can be. Yeah, I think you can. Let me think through the security model here. I think that depends on intent. Intents are how you send information between apps and Android. And I don't know if you can set that up. But hold on. Let's go back to our... start activity. Okay. Start activity. No intent supplied. Let's give it a lowercase n and see what happens. Activity class does not exist. Bad component name. .admin. So you're still, it's just in root here, but that doesn't matter. AppSec / oh, see, look at how it's named. So I see. So I do think we were getting that wrong. See how it's kind of like double path like that? Oh, actually, it should have the name right there. Ah, perfect. Yes. I can't copy paste, I'm pretty sure, but I can at least have it up. Yeah. OWASP.sat.agoat. Insecure storage. Yeah, there is an insecure storage activity. Yo, that worked. So we opened the insecure data storage. Which cool. First try. But that wasn't the one I wanted. I wanted the access control view activity. Access control 1. It's really annoying. Access control 1. That's it. So without entering a PIN, we were able to get to the download invoice. That is really cool. Okay. Okay. Maybe I can make some money doing this. And then log in without PIN by launching the activity. Understand the custom URL scheme. Log in using custom URL scheme without PIN verification. Download invoice without PIN verification. Okay, so we kind of had that going. So we're here, and let me clear out all the garbage from the proxy. And go back to here. We'll hit download invoice. Invoice is being downloaded. Doesn't appear to have done anything. But maybe... if we hit download... So it just says invoice is being downloaded. Connected, no internet. Man, what? There's internet. It's slow as molasses, but there's internet. Okay. This download invoice doesn't do anything. But we got to the insecure activity. So that's really neat. All right. Czar has asked for insecure data storage. So here's some SQL injection, maybe. So let's see. What is insecure data storage? Understand different storage mechanisms available. So shared preferences. Aha. So what is shared preferences? Identify where, how sensitive information is stored. Vulnerable code and the risk associated with it. So I don't know what we're going to get here, but oh, Packet Hub, thank you. Share preferences are created using the share preferences class. Below is the piece of the code used to store. Okay. The app directory stores the shared preferences. Aha. So it is stored here once we save it. That's kind of what I was looking for. So let's go back to our app. Let's create a user. Bob, 1, 2, 3. Save. Data saved. Okay. Let's go back to our trusty terminal emulator here. And oh, you know what? I'm not in where I want to be. Just kidding. Not in the same directory I want to be. Because I want to be in data. Yeah, there we go. And we're going to cd OWASP. That's it. There it is. cd shared prefs. And if we cat users.xml. Look at that. Data stored in plain text in shared preferences. So that is how we do that. Now, I'm actually curious. Can we see that in the file browser? Even this garbage file browser? No. Because it won't show us the root of the file system. None of these actually downloaded. What if you make a symlink to the root file system? Yikes. That's an idea. Actually, I forget where I am in the file system here. I don't think I'm in system. Yeah, I honest to God forget where I am in the... That'll take a second. There it is. That's what I wanted. CD storage. Emulated 0. Yes. Function not implemented. Can I do it to another location? No. Bummer. But okay. So we saw shared preferences being stored insecurely, so that's something. Vulnerable code, risk associated with it. I mean, pretty obvious, right? There. Okay. Shared preferences part 2. Oh, excellent. Go to next level by scoring 1,000 points. Click on score button will give you 1 point. Don't click the score. Oh, 10,000. Don't click the score button 10,000 times. Okay, score is 1. Let's see. CD data. OWASP. CD shared prefs. Cat score.xml. Oh my god, I've got Vim. Yes, yes, yes. I am a happy camper. You want to tell me about those shared preferences? Oh, I gotta reload it. I see. Hey. Click on the score button will give you 1 point. Don't click the score button 10,000 times. So do I have to kill the app? Yeah, I think I have to kill the app and bring it back up. Because it's stored, it's loaded the preferences like when it loads the app. Yeah, that's what I'm thinking too. Sorry. Because if I hit click, did it reset it to 0? Nope, it's still there. Okay. There it is. Very nice. All right. SQLite. Presumably, this is going to be in the same location. Oh, there's databases, right. There's a databases folder. There's AGOAT and AGOAT journal. I'm not still entirely clear on how this can be exploited apart from horizontal vertical priv escalation. Are these files available to all other apps running on the system? That's a good question. I don't think they are. Yeah, each of them has, unless you're root, each of them has its own user. Each app has its own user. So I don't think that it's kind of like exploitable that way. Yeah, so I want to be clear that I am not trying to pull a you-know-who here and say, like, oh, this is terrible, and, like, apps are the worst. Apps are the worst, but not for that reason. This is not, like, we're not looking at practical remote exploitation here. What we're really looking at is how can insecure programming practices reveal information that the app developer thinks is secure. And I think it is a bigger deal than you might think, because I think developers do, like, if they're not careful, they'll think, oh, okay, the user can't look at the stuff that I have in the app because, you know, it's all hidden behind the screen. But no, in fact, the data is coming from somewhere and the data is getting saved somewhere, and this is how you would do it. So I think it's much more like, what could a malicious, researcher that has skills like this could do. They talk about this because it's a legit issue. I mean, I think it is a legit issue. Think about it this way. Put a couple of these together, and now you're in some really scary territory. So let's say that you did have an API that had a hard-coded encryption key, and you were able to get that. And let's say maybe that it also had, like, IDOR in the API. And not only are you able then to get the credentials you need to access the API and manipulate the data, but then also it wasn't secured on the other end to prevent you from getting whatever kind of data you want. What's an API? API means Application Programming Interface. And to be honest with you, Warplays, the term can be a little overloaded. We use it to mean a bunch of different things. But broadly speaking, when we talk about an API, we're talking about a way for one piece of software to talk to another piece of software. That's I think the broadest definition. In practice, what we're often talking about when we talk about an API is a network-based API, where an app, for example, will make a request over the internet to a listening server, ask for data, and the API sends it back. So kind of a PC uses IP to talk to another PC. We're several layers up the OSI model here. An API is in the application layer for sure, right? Because we can send it using HTTP. But yeah, we are sending data one place or another. Actually, here, let's take a look at an example of an API, just so that there are no confusions. One of my favorites is Swappy. So Swappy is the Star Wars API. And this kind of gives you an idea of what kind of these kinds of network-based APIs might look like to load data for apps. So, you know, you hit the API, ask for people. I like doing starships, of course. Starships, and we'll do, 10. And what does that give me? Oh, yes. So that gives me the Millennium Falcon, right? So I'm using the identifier here of 10 to get the specific starship that I want. I could also ask for a bunch of starships, right? I think it would give it to me in pages of data, and it has what I need in terms of the information. So often when we're talking about APIs in the context of apps, this is what we're talking about. It is a way for the app to retrieve data and send data to remote computers and from remote computers. Okay. See what else we got. It is really cool. I actually love API programming. I think it's a lot of fun to design APIs. Oh yeah, so we were in here. Databases, and there's no way I have... Okay, I don't have SQLi. I guess I could install it, but also I could, like... I don't have curl. Interesting. So, like, could I get the data one way or another? I guess I could copy the database, right? Agoat has 20K in it. So I could copy a goat to storage emulated 0 download. Maybe as SQLite 3 client. Oh god, it does have SQLite 3. That's stupid. All right. Schema. All right. Incredible. Yeah, and don't store that crap in plain text. I actually want to see if that copy, though, did work for exfiltration. Yep, there it is. So we can actually get it that way, too. Awesome. Can I just drag these away? No. Google Play Protect is turned on. Get that out of here. No wonder none of this stuff downloaded. No. I still wanted my Astro file browser. I'm never going to get that app, am I? Just never going to happen. Okay. Next. Temp file. Identify how where sensitive information is stored. Vulnerable code. Okay. So this one we're actually going to have to look at the source. So let's go over to Kali and JADX. And so we're saying insecure storage temp activity. Right. This is the one that we were just looking at here. So cool. Some metadata for some reason. Not really sure what that's about. Let's see. On create. So content view. Cast insecure temp, insecure storage temp activity. Here we go. Here it is. So we have file create temp file users temp in the data dir. So if that's true, then this is kind of all of a piece where if we know where the application is storing data and we know that yeah, look at that file right there. Cat users. It's saving data right there. Look at that. Pretty gnarly. Okay. I feel like I have to say, I actually feel like as a teaching tool, AndroGoat is doing well. Like, I'm learning a lot about how to look for stuff in an Android application that might be sensitive, and might it result in a vulnerability, you know? So congratulations to the developers of this. I think it's a fantastic pedagogic tool. Yusuf, I missed your follow, but thank you so much for it. I think the last one we have in this category is external storage. What is external storage? Identify how where sensitive information is stored. Okay, so let's go to the external storage. I think it's SD card right here. So username, password. This data is stored in SD card on whatever, and then get external storage directory. Create temp file, users, temp. Yeah. So we'll see if this actually works, because I don't have an external SD card plugged in to this. Yeah, I don't think this is going to work. But if it did, we would be able to look for external storage and then save it there, right? The days of external storage, I feel like, are kind of over for Android Android phones. I could be wrong. Let me know if you have a modern Android phone that that uses external storage. What some of the OnePluses still do, I think. Honeypots, thank you so much for the subscription. Really appreciate that. All right. Very similar to web app exploitation, except the app is both the server and the browser that renders front end. I wonder if there are vulnerabilities like SSTI. Maybe? I don't know. So I'll tell you what, the reason why you can get XSS is that in many cases, actually, let's go back to the Visual Studio. This is a Xamarin app, so maybe not. But one of the things that, application developers will do to save money and time is, instead of using Java or Kotlin on Android and Swift on iOS to do the development, basically what they'll do is they'll have this kind of wrapper project for Java or for Android or for iOS, and all it'll do is open up a little local web browser and point you to a local like index.html, and then write the app in a web language, right? Do React or Vue or whatever, and also all of your real application code is JavaScript, because JavaScript developers are a little bit easier to find than native mobile app developers. And just to give you a little bit of history on this, this technology started from an Apache project called Cordova. Still around, by the way. But people have taken this and run with it. And this is how this works, right? You start with Cordova, and then, it creates a specific project for you in. So hold off on Discord. So Discord is not actually one of these apps. Not quite. Discord is a little bit different. It's not a Cordova app. So I think it was like Meteor, I think. Meteor.js, if I'm remembering correctly. Yeah. Took Cordova and ran with it. There have been a bunch of these others. But, it's kind of how this goes. Now, what SAR is talking about is the idea of wrapping an app in a browser window. So Discord, Slack, actually even Visual Studio Code, Notion, a bunch of apps these days are running in what's called Electron. And Electron is a little bit different than Cordova, because what Cordova does is it gives you a way to actually build a native application for iOS and for Android from a web language. What Electron does is, that Electron fires up, when you fire up Visual Studio Code, or when you fire up Discord, or when you fire up Slack, what you're firing up is a Chrome browser instance that looks like an app. It is packaged to look like an app, but under the hood, it is an application, it is Chrome that is pointing to a specific HTML file and specific JavaScript to run your application. There's some extra stuff to it, like Electron has its own, here that comes again, API to create menus and things like that, so it doesn't feel like a web browser. But at the end of the day, that's really what you're looking at. So just let's look at VS Code here, right? This is VS Code. I've got Offensive Notion up and running. This menu up here is being generated for all intents and purposes by the Electron API to give me this menu here. And it's disabled a bunch of stuff. But you can try this in in Slack, I think still, you can do like Control R to reload the page and maybe F12 to open up the inspector. So you can actually see how there's like the web browser underpinnings of it. But yeah, so Electron was a solution to get platforms across, like get applications on Mac OS, Linux, and Windows from one single code base. The problem, of course, is that those applications are a little chunky, and especially in the memory department, because you're essentially running a whole web browser inside of for that application. So you're launching a bunch of Chrome instances every time you fire one of those things up. And by the way, it turns out that, you know, Chrome and any Chromium-based browser can kind of do this thing, not to the same level, but you can appify any of them. For those of you who don't know how to do this, because it's kind of neat, like this is how my music player works, actually. You can create app shortcuts in your browser with tools and more tools and create shortcut. That creates an appified shortcut to a page, and it'll look like that. You can also launch apps. You can also launch apps this way if you go to, if you do like, I'll do Edge because we were playing with this. If we do C, program files, Microsoft, Edge, applications, msedge.exe, and we give it app equals, and we give it like notion.so. Look, no window or like no menu or anything, but it's still the browser, but it's like appified, right? It even has the right icon, sort of. Right, it's taking the fave icon from the page and using it there. Okay. That was a bit of a tangent, but it's all good. Input validations. I want to get cross-site scripting on a mobile app. Let's go. Input validations. Come on. Okay. Something appears to have gone horribly wrong. Oh, there it is. Something horrible happened. I don't know exactly what. Let's try to make it do something without having to see it, though. You know? So we're going to delete the sites here. I think the alert window might be out of the viewport. Yeah, I think that's right. Sorry. So what we're going to do is we're going to do a, since we're blind, we're literally going to do a blind cross-site scripting attack where we make it fetch something. Hi there. So that's wild, because if you do it as like a stored cross-site scripting, right? You know, that could load up anytime somebody saves the app. And imagine if that were something, imagine if there were stored cross-site on like a forum, like a Reddit app or something else like that, where people are going to be loading your content, but you've injected the cross-site in there. That's crazy. Yeah, exactly. In a messaging app. Totally wild. I found cross-site scripting in a messaging app. Not one that was eligible for a bounty, unfortunately. That's like the story of my life. But yeah, that was a cool one too. because it was they had filters on it, but I found the evasion for it accidentally by like errantly pressing enter. So I added a carriage return, and that was the bypass for the cross-site filter. All right. Let's go. SQL injection. Ooh. Please complete insecure storage SQLite exercise and ensure minimum 2 users are created. All right. I'll go do that first. What did they just Google me for? Gen 204. Interesting. Data saved. Okay. So with that, we should be able to go do the SQLi here. Steve or 1 equals 1. That's stupid. See that toast at the bottom there? What happens if I just give it a quote? Oh, great. Thank you for the error message. Very helpful. Okay, and then web view. Understand what is web view. Access sensitive information using URL apart from URL. Understand what is set allow file access. So web view, like this will load my site, right? Sure will. Access sensitive info using URL. What the hell just happened? Something it didn't like. So access sensitive info using URL apart from the web URL. I don't understand what they're trying to say here. Understand what is set allow file access for web view. That we can just Google. Web view set allow file access. Set allow file access. Enables or disables file access within WebView. Note that this enables or disables file system access only. Assets and resources are still accessible using file, Android asset, and file Android res. So what are some things that we would want to get off of the system? Let's look at the JADX to see if it's set. Where's that web view? What files do we have access to? Yeah, that's a great question. So I want to see insecure, no, input validation, web view, URL activity. So web settings, JavaScript enabled. Apps should not open file URLs from any external source in WebView. Don't enable this if your app accepts arbitrary URLs from external sources. So can I straight up do like Etsy password? No, but... Probably not, because it's not, you know, the app isn't running as root. So, but then again, so everybody's got to read. Oh, I'm looking for it. I don't see password in here. I'll try Etsy hosts. That exists. Okay. So what are some things that you would want to get off of a file? So hold on, like Android password. Let's see. Does the Android operating system have files like Etsy password? This thread discusses how that is done. There is a stub for mapping Android ID to passwords. But like, it's not going to have a password, you know? Wouldn't you be able to access other apps data with this too? It's entirely possible. Yeah. If you knew what the app ID was that you were trying to access, right? Because it's not like Google Play. I guess you could, like, if you knew Google Play was on there and you knew what the app ID was of that, you could probably get something like that. Or even the browser. There you go. That's something we could try. We try to get browser secrets. So com.google.android. There it is, com.android.chrome. Let's see what you got in there. cd com.android.chrome. There's shared prefs. Okay, nothing there, but there it is. Now I'm seeing files that looks... There we go. So if we go to default, this is the default profile. Can I read it? Oh, I broke this terminal session, but good. Let's try it. Let's kill that and bring it back. Yeah, can you read it? I'm trying to find a plain text file on there. Android.chrome app Chrome ls cd default. Cookies. That's just data. Dang it. So I think the answer is, could we get it? All right, we'll try. App Chrome default / cookies. So file. Oof. Okay, we're definitely breaking stuff. Binary patching. It's interesting. Data pom.android.chrome / app chrome / default / cookies. Okay, I think it did load, but then broke immediately because it wasn't plain text data. But now, the other thing that I think might be interesting is... this is always fun. Let me fire up a replit real quick. Okay, so we're going to make a replit real quick. But I don't care about that. We'll go to script.js. We're going to say alert. Document.cookie. Nah, that's not going to work. I do want to see if I can make it happen, though. Easy days. Run. Yeah, thank you. And then we'll take that. Oh, of course. Goat test.michaeltaggart2. Goat test.michael.repl.co, right? Yes. Just says hello world. Come on. Oh, but it didn't do the thing. So the page loaded, but my JavaScript didn't execute. Disappointing. Okay. I think we played with that one. OS command injection is grayed out. I don't know if that's because it's missing or what. Nope. OS command injection should be there. So we can... I think we just have to access the activity the way that we did before. So let's try that. I'm interested in OS command injection. Don't know about you. So is AM start activity, N being OWASP dot sat dot agoat slash OWASP dot sat dot agoat dot input validations OS CMD injection main to activity. Wait, what? So, oh, it's one of these. All right. So, be like 8.8.8.8 LSAL. Did I not hit run? I wonder if this thing is actually working. Oh, we killed it. Okay, let's see. 8.8. I think maybe this one isn't ready for prime time. Yeah. Keyboard cache. That's scary. Android keyboard cache. This has been a learning journey tonight. Oof. Data, com, Google, Android, input, method, Latin. Oh. No. Okay. So. Thank you for typing that in plain text. Okay. So now... Okay, nothing in there. That's a relief. But that's because I wasn't using... Oh, because I was using the keyboard. Data package name. Okay, I'm still not seeing any data in here, which is, I think, fine. But perhaps if I had used the on-screen keyboard, I would have. Can I turn this on? And would that change the situation? Oh, okay. So let's try it this way. God, this is really funny. Okay, that's really annoying. So let's turn that back off. And then let's go back over to our terminal. com.android.input devices, input methods. Still nothing in there. I guess that's good news. Although, it does seem like that's where things would live. Alright. I'm just curious what... Get access to administration functionality. Binary patching. So here, we would like patch the app and then reload it, I guess. And if we look at JADX, we go input... Or no... What was that called? It was just called binary patching. Binary patching activity. You clicked on administration button. Create. Text view. Is admin text. Text view. You are admin now. If this dot is admin. Private boolean is admin. This dot is admin. So we'd have to like edit it to either... Oh, I guess you know what the easy... So here's the... Yeah. This is like the fake assembly-ish stuff that gets disassembled from the decks. So I guess the easy thing we could do is flip that, right? To say if not is admin, and then give that. How does that work? Smalley patching. Yeah, exactly. Okay, I don't think it really told us how to change it, though. Can we do it with JADX or not? So, yes. Can we start editing this? Or can we save it as a Gradle project and then... No. And then recompile it. I get the idea here, but... this Medium article does not clarify how we do it. Packet pub's like 10 words that it's going to give me is probably not going to. Dex to jar, change the source code of this APK tool. I see. So basically it is that, where we export it, we turn it into a new project, and we recompile it. Okay, I'm not doing that right now. But that's cool. I think this was a pretty neat introduction to mobile app testing. I think it's a good place to end for tonight. It's a good starting point for doing this kind of stuff on the stream. I learned a ton tonight. I hope you did too. Totally new environment for me. I haven't done any of this before. Cool that we can do it through Visual Studio with that emulator and Hyper-V. Not going to save that app. But I think that Android x86 worked just fine for what we're doing. And the fact that we can route all our traffic easily through Zap is pretty cool too. So I think we're going to do some more of that at some point and maybe take on, because, you know, there have been CTFs that have had challenges like this that I haven't touched because I didn't want to do mobile stuff. So maybe we'll take on some of those. But for now, I think we're going to call it a night. So let's see if there is anybody else who is streaming. Nope. All right, well then I think we're going to just send you all on your merry way, but I will be back tomorrow night doing some programming. The plan is to get back to Nimbuster and do some Nim after I've been in the Rust rabbit hole for so long. But get Nimbuster ready to go with an async model rather than a parallel model, so that it'll be really, really screaming fast, even on a single CPU. So that's the plan for tomorrow night. I'll be back at 5 p.m. Pacific. Until next time, friends, please be good to yourselves, be good to each other, and happy hacking. We'll see you next time.